Welcome back to our series of solution and explanation to competitive coding. Today we are going to solve LeetCode question number 242, that is valid anagrams. So let me read the question first. Okay, so this question says that given two strings s and t, return true if t is an anagram of s and false otherwise. So okay, question is saying that we are given like two strings s and t, and we have to return true if t is an anagram of s. Otherwise, we have to return false if those two are not anagrams. So what an anagram is that? An anagram is a word or a phrase formed by rearranging the letters of different word or phrase, typically using all the original letters exactly once. Okay, so how two strings or like phrases are anagrams? To be anagrams, to be two strings to be anagrams, they should be actually they should use one string should use all the characters of other string exactly one times, and it should use all the letters that are present in other string and rearrange them to form a new string. So like in our example one, if suppose s is the word anagram and t is the word Nagaram, and if you arrange the words of like s, and we can found that we can use all the words of s to make this a string of t, make this a string like t, and we have to use all the words and exactly one time to make this a string. So in this case we have to return true because these two are anagrams of each other. And like in example 2, although there are three characters in both the strings, but we can't make the word car by rearranging the words of our string s, that is red, because we can't find the word C in our previous string, and we left with our T character because we don't have to use in our T string. So in this case, we have to return false. So let me read the constraints. Okay, so constraints are given that okay, 1 is less than s, or length is less than equals to. Okay, so the length of the both of the strings would lie something between 1 to 5 to 10, 5 to 10 power 4, and s and t consist of lowercase English letters. Okay, so both the strings consist only of lowercase English letters, so we don't have to care about upper cases and like other characters and numbers. Okay, so let me go to the solution tab. So suppose this is our string 1. Okay, suppose this is our string 1. I can say, let me take the pencil. Okay, so if this is our example 1, so what we can do, the brute force approach tells us that the most basic thing what we can do is that we can sort both of these strings and check them character by character. If they're equal, we can return true, and if they're not equal, we can return false. Suppose in this case, this is our example 1 and this is our example 2. So after sorting, suppose if we sort both the strings of example 1, that is room and more, so we get after sorting. Okay, let me write it here. So our sorted string would be something like, okay, let me do it. It should be E, then M-O-R. Okay, E-M-O-R. And for this one, after sorted one would be something like E-M-O-R. Okay. Okay, so both are same. After sorting both the strings, both are same. Then what we can do is that we can start checking. After sorting, we can sort both of the strings and check them character by character. If all the characters and their respective indices are same, like for first indices both have E, and for second indexes both have M, and for third index we have both as O, and for the last index we yes, observe that all the characters in the strings of both the strings are after sorting are same, so we have to return true. And suppose for in the second case, like in this case, after sorting, what we will get is okay, so or sorted would be something like okay, B, then E, then R, D, and U. Okay, this would be this, and our second this array would become after, so sorted array would be okay, it should be C, E, and then R, D, and after that U. Okay, so when we start checking character by character, this is string. So what we will find that our first character after sorting is not matching. That is, in this string we are getting B and we are getting C. So we have to return false as an answer for this string. But this approach would take us at least of n log n time to sort our array. So n log n time. Okay, so it would take n log n time to sort our arrays. At least we need n log n times, and obviously n space. Okay, this is time, and obviously n space of n space to put our sorted strings to match them. Okay, for both the cases. So it is like O of n log n and O of n solution, but we can do it better by using some extra space or some space or something like that. How we can do better is that, let me show the approach. So let me remove this. Okay, so if this approach works, okay, this approach works fine, but it is taking off and login space time and off login time. But if we do something like this, okay, suppose we create two arrays of, okay, so this, suppose we create two arrays of like all the characters from A to Z, and we increment the value whatever we find, and we don't have to repeat again and again. Let me show how it would work. Okay, so suppose I've created two arrays of from A to Z for both of our examples. So what we are going to do is that we'll do that if suppose we are on the first character. So what we will do is that if we do like R in this string, R is our first character. So if you delete if you do like character R minus character A, what we'll get is, suppose we'll do initially A minus A, because both A's have similar ASCII value. So what we'll get is 0, and so we'll increment our, but initially when we create our array, all the positions are filled with 0. So whatever the value we get by subtracting our A from our initial character, we'll increment that character, like the position, the value at that character. Suppose we do R minus A, so we'll get the value whatever it is. I mean, this, we'll get this value, because if we do A minus A, we'll get this value, like 0. And if we get B minus A, we'll get 1. So if we get R minus A, we'll get this value, and so we'll increment the value whatever is present in this, like whatever is present in R, we'll increment it by 1, so it will become from 0 to 1. For next time, we'll do O minus A, O minus character A, we can say. And so whatever, so we'll get the value from 1 to, like, if we are like subtracting character from character, we'll get like the ASCII subtracted from that value. A is something 97, so A is 97. So whatever it is, we'll get the, so we can increment the position of our array by 1, whatever value we are getting. So when we delete O from A, we'll get some value of here, and we'll increment this value by 1. So initially it is 0, so it will now become 1. And again for m, if we do m minus a, we'll again get this value, and we'll increment it by 1. And by doing m minus a, we'll increment our m value by 1. And by like deleting e, but subtracting a from e, we'll again get some character value that is equals to 5, and then we can increment whatever the value present at our E or fifth index. And when we do for this one, and when again we do for this one, or we can do is that we can subtract it to make it all 0, or we can do is we can increment it. Okay, we can simply increment, we can make another array or another array of the same A to Z, and we can increment again when we reach here at m point. Then we found that we have to increment this value, and again when we move to O, then we will increment this value by 1, and when we move to R, increment this value. Okay, when we move to E, we have to increment this value. So when we compare these two strings, if all the values like from 0 to Z, from like A to Z, if all the values of both is like arrays, if this is A1, A1 array, and if this suppose we create under array A2, and if all the values of A1 and A2 are equal, then we can return true, because if all the values are equal, that means all the characters are present in same number of times in both the strings. That means both the strings are anagrams. But like in this case, when we start subtracting from our, it's like in example number 2, when we subtract from A from B, we get the value as 1, so we'll increment our B, then we move on, we increment our U by 1, and then we move to third character, we increment our T by 1, then we found that our fourth character is also T, then we make our 1 to 2, okay, then this will become R2, okay, then again we move to E, then we increment our E by 1, and again we increment to R, then we increment our R by 1. But for like, if we have another array for T, and we created another array, so for this for like our anagram, or like second string T string, we'll need that, okay, first character is C, so we will increment our C by 1. If the second character is U, then we can increment our U by 1. Then again we'll increment our T by 1. Then we found that again it's T, so we'll increment it to 2. Then we'll increment our E by 1, and finally we can increment our R by 1. So when we start comparing both of these strings, the value present at the indices, we found that B would not match. So if any of the value would not match, and our C is also not matched, if any of the values not match, we can return false. So let me code this solution so that you can finally get what I'm trying to say. Okay. So initially we have to make two like arrays of 26 lengths. So I can do is bad int integer of, I can say str1, okay, str1 array, and is new int of 26 size. Okay, so this is our first, and we can do our int str2 of arrays, and it will also be of size 26. Okay, so int 26. Okay, now what we can do is we can loop over our first string to increment our count of first, like int1. So we can do is for characters, suppose ch in our string 1, so we can't directly access characters from a string, so we have to make s dot to char array. This function actually converts like a string to its equivalent character array. Okay, so now we can s dot to char array. Okay, now we can do is that we can increment our str1 position by ch minus a. Okay, oh my bad. Okay, so we are and we can do plus plus. Okay, so the index of string 1, whatever the value ch minus a returns, will be incremented by 1 whenever we meet any of the character in this char array of our string. So we can do it again for our t. Control c and Control v. Now we have to do this for t dot char array. Okay, and we have to increment our string 2. Okay, now we can finally look over both the strings at a time and check for the if both the characters of both the strings are like the value present at the indices of both the strings are equal. If they are not equal, we can return false, otherwise we have to return true. Okay, so we can do our third for loop. So for int I equals 0, and because length of both the strings are 36, so we can do is I is less than 36 because it is starting from 0, and we can do I plus plus. Now we can finally check if like character at indices of both the string str1 of I is not equals to str2 of I. If they are not equals, we have to return false, that is return false. But if this is not the case, like if both of the strings are equal, then we have to return true. So let me check if it works or not. Okay, if there are no typos. Oh, there is one. As a to char array. Can't find symbol to char array. Okay, what, it couldn't find character. Okay, it is function basically. It's not a we are operating over the string, so we have to make it as function. Okay, so this is function. You have to remember that. As two-char array is a function, and we have to put the sign of function. Let me check it again if there are no typos. So it did work. Let me submit our code to see if it's optimal or not. Yeah, it is 100% faster, and because we use some of the for loops only to iterate over the array, and it beats 66% of, in the case of memory, it uses only 39.5 MBs and it is 1 ns. So hope you enjoy learning, and if you have better approach, you can comment in the comment section below. And as always, thanks for watching.